Yeah, okay. So thank you for staying this late and still listening to this talk. I'll try my best to draw a balance between speed, and I don't want to rush this talk, but at the same time, I want to be respectful of your time and the fact that it's a working day tomorrow. So this talk is about judging the LLM-Judge. I have the misfortune of following Mitesh on a talk the second time and getting overshadowed by him. But on the flip side, I'm going to use a lot of his jokes and also some of the concepts that he's used. When we are looking, so let's talk about the genesis of this talk, right? The last time I presented, we spoke about using an LLM-Judge for performing evaluations. And somebody in the audience asked me, so you're using an LLM to judge an LLM. Why should you trust this? Like, isn't this like logic circular? How can you trust the LLM-Judge to do a good job? And that's where I thought, okay, yeah, there's something to that question. So let's actually dig a little deeper into what that entails. So that's a little bit about me. Yeah, I started a new job recently, but yeah, I'm going to just go through this stuff a little faster. So let's get to the point of what are evals. And I'm going to add a little more to what, like in the previous talk, we spoke about what skills are going to be still relevant when AI is going to do that which we have always taken as our special skills, right? Like whatever set as a part of the job market. I would say that there's one more skill here in terms of qualifying and benchmarking AI systems themselves. Now that's a new category of skills which will be relevant in the future. And I don't think AI systems can do this themselves because they lack the mental model to figure out what is important to you. You are the human who figures out what is important to us, what is value to my customers. And I think that's the part where AI is going to do a poor job of mimicking it because it's only going to be a percentage of fidelity at the most, right? It's never going to be 100%. And that's by definition. And what Jerry Weinberg, when it comes to definition of quality, said it's value to someone, and that someone is a human being, right? And the challenges with evals and how evals are different from automated tests, most automated tests, is that both the input space and the output space of an eval is typically unbounded. When you go to ChatGPT, you can type anything into that chat window. You can upload any image you want. So that's an unbounded input space, and the output space is unbounded for even a bounded input because of stochastic, probabilistic, and temperature and things like that. Non-determinism in a nutshell. So how do we test non-deterministic outputs in an automated manner? What I was trying to hint at is LLM as judge, which is what I demonstrated in my last talk. And what you're doing in this case is it's very lightweight. You have a non-deterministic output, but you also have some system that can mimic human judgment, stand in for a human, and you can do that in an automated manner, right? Actually, you're doing the same thing with oracles when it comes to test automation. Those oracles are typically simpler, and an LLM-Judge is more complex. More complex also means more entropy. But whenever you say LLM-Judge, this is the first thing that comes to my mind, right? And this is also the genesis for this talk and that question. There are many studies, the most prominent of which that I was able to find was conducted by a bunch of Stanford University researchers, where they found that LLM to LLM, LLM judgment alignment was to the tune of 80% with humans across a large enough set of data tasks that span different domains. And that is more than human-to-human alignment, statistically. But that said, that is their benchmark. You still have to build your own benchmark because that context is not your context. But how do you do that? How do you take an LLM-Judge and align that with human judgment? At the end of the day, any LLM-Judge is only as good as the human that they are replacing. And that's why human alignment is the key. And that's what we are going to look at a systematic process as to how we can do human alignment of an LLM-Judge. And you're going to be involved because you're going to actually be providing the human judgment that is needed to see if a question is right or not, right? And yeah, so this is something that has captured our imagination for as long as we've had robotics. Asimov's 3 laws of robotics are only about human alignment. And there's also a 4th law. I think he also added a 0th law. So this is how the demo is going to be set up. we are first going to have a few questions with ground truths. And in this case, it's just going to be 10 questions. For those 10 questions, we have established that this is ground truth, which means this is what we take as the standard answer for this question. And then we get the RAG model to generate a response. So that's your system under test. So that's a system with AI in it. And once you get that answer, you have an LLM-Judge evaluation, which is going to be done in an automated fashion, like I said before. But we in the room are going to provide the human judgment. And then we can see, we can reconcile the two and see how that goes. So the ground truth source is the 37 Signals handbook. So let me just open that handbook. That's also what I demonstrated in my last talk. And it's a nice data set for a demo like this because it has a bunch of chapters where you can have objective question and answers, right? So you have all these different data that pertain to this company. Employee only medical coverage, that's a fact that you can check right there. You also have some questions where you can build decision-based, you can ask it to use decision rules to arrive at an answer and so on. So you have a diverse set of questions that you can still ask with this. So now let's go into the demo itself. And to start the demo, what we would need first is, like I said, we have this set of ground truths. And so yeah, you have, I think what you need to pay attention to is the fact that there's a question here, and you don't need to read the whole question. So how many days of paid vacation, for example, and then there's an expected answer here. And this set is nothing but a JSON file with questions, answers, and there's a little bit of metadata there as well. And there are about 10 questions here. But don't worry, I'll give you a better user interface to see this. We will not be doing this evaluation like this. So you have a bunch of ground truths, and you have questions based on the ground truths. Now you can feed those questions to the RAG model and get the answers. And you want to see if those answers are aligned with your human judgment, right?
That you like them, that you think they're correct.
Yeah. So in order to do that, let's just run this script, right? Like we just say generate RAG responses. And once you do that, it's going to give you another results file, which is another JSON file. And as you can see on the command line, this RAG model is now answering these questions that are being fed to it one by one.
Oh, come on, man, for all mini.
Yeah, so I just...
That's the point. That's the point.
There's a point, there's a reason I chose 4.0 mini.
Okay.
Yeah, but it is an old model. So those are the 10 questions we have seen. The first question was how many days of paid vacations does 37 Signal offer each year, and what is the maximum value of vacation days you can bank through rollover. This is the expected answer. This is the RAG response.
Yeah. Looks similar.
All right, so is this an acceptable answer? Okay, I see a thumbs up from the behind. Okay, I see many thumbs up, so the human verdict is acceptable. And here, if we have evaluated this with the LLM-Judge, we'll have a verdict. But in this case, we've still not done that. So let's go ahead and do that. So now I'm going to take an LLM-Judge and then get the LLM-Judge to evaluate the RAG responses as well. And there you see that there are some which are passing and some which are failing. Quite a few are failing, actually.
That's expected.
And what is interesting is both the RAG model and the judge were made with the same model, right? So in spite of that, there is there's a reasonable failure rate. Now, why is that happening? So we saw that this was acceptable, and now if we reveal the judge verdict, it is acceptable. So human and judge, in this case, agree. Now we can go to the next question. In most cases, a domain expert is going to be doing this.
Yeah.
And in most cases, domain experts, are not very comfortable with code, so they can do this in a user interface like this. And the second thing is you're going to be you're not going to have them every single time you change your application. So you need a good enough proxy for a domain expert for them to be able to stand in.
For his judgment to be.
For their judgment to be baked into the, into the eval. So in this case, it's a slightly longer question, and it talks about invoice accounting on the left side. Okay, the question itself, I forgot to point there. What is Queen Bee at 37 signals, and what can an employee do with it? On the left side, you have the expected answer, and the right side, RAG response. So go ahead, give me a thumbs up, give me a thumbs down. All right, 2 thumbs down, 1 thumbs up. Let me see if I'm going to scroll further. Let me see if I see any other thumbs. Okay, several thumbs down. Somebody tell me why you given a thumbs down.
The broad description. It's very broad.
Okay, so
Context.
sorry.
There is a function for
There is retrieve context. You can look at Queen Bee, and this is where this is the source for writing your ground truths.
This is the chunk from RAG.
This is a chunk that was retrieved by the RAG system. So RAG system used this to arrive at its answer. And yeah, you can see that the ground truth is like far more precise, or far more concise at least. And in this case, the LLM's response is too long. So you can say LLM response too long, or yeah, RAG response too long. Now when I save that commit, I can just reveal the judge verdict. In this case, that's what even the LLM-Judge says. The LLM-Judge also says it includes extraneous detail. So we go further. Let's look at some question that the LLM-Judge marked as wrong, right? So, okay, this is a long question, so let me skip through this. All right, so let's look at this. List the 4 chief communication mechanisms 37 Signals uses to keep teams aligned in their async remote work, and for each one, explain how often it is required or when it's due. So I'm going to scroll through slowly to the expected answer and the RAG responses. Yeah, so you have daily check-ins. You have weekly check-ins.
Those are kickoffs. Team heartbeat is missing.
You have kickoffs, and you have kickoffs on the left as well. And the team heartbeat on the left side.
Yeah, is there.
And you have heartbeats. So thumbs up, thumbs down.
Well, okay, yeah, it's okay.
All right, I see more thumbs up. Okay, Mitesh is somewhere in the middle. So that's actually a good point, because one thing that I'm doing here with the evaluation framework, and this is done by design, is that I'm going to say you have to either pick acceptable or not. So if your thumbs middle, you're mostly going to say not acceptable, because you're still not satisfied with something, right? Your system is just not there. And this is very helpful. This is more helpful than, I would argue, giving a scale between 1 to 10. Because with 1 to 10, if you make an evaluation of 7 and 6, it's just going to start debates as to whether that is good enough or not, right? Instead of that, you have you're forcing a binary response here, and this is actually what is recommended. And here as well, we are trying to build a system and a process. The process is more important than the particulars that we are seeing here. And in this case, yeah, I saw a few thumbs up, so I'm going to give acceptable. But if you reveal the LLM-Judge, it says not acceptable because the roles of kickoffs and heartbeats are swapped in the response. The LLM-Judge also wants the same order imposed, right? And why is that the case? So let's take a step back and look at what the LLM-Judge is actually doing. And there's a certain system prompt that is configured in the LLM-Judge. This is the prompt. You're evaluating whether a RAG system's response correctly answers a question given the expected answer drawn from a company handbook. Decide whether the response is acceptable. To decide whether the response is acceptable, it must convey the key facts presented in the expected answer without contradicting them. Minor phrasing differences are fine. Missing key facts or inventing facts are not supported by the expected answer, and those are not fine. So reply with strict JSON only, no prose, no code fences, acceptable answer true or false, and with reason, one short sentence. And that's the reason that is what we are seeing there, right? Now, you can really modify this to state that ordering of facts is completely fine. Like if you can order the facts. So this is called an evaluation rubric. And this is really, really going to be important as to how you configure the LLM-Judge, because this is determining the LLM-Judge's behavior. You can even have like a multi-step process. In this case, it's just one process and you're giving acceptable or not. But you can also have like a systematic process to say, this and this is acceptable. You can even have like decision flows here.
So it's as if you sit with a subject matter expert.
And you would be performing this evaluation not for 10 questions. It would be more to the order of 100 to 200 questions. Yeah, you typically want to do this once thoroughly for a large data set. And then you can use that evaluation run as a benchmark. Think of it almost like snapshot testing when it comes to UIs. You have like one version of the UI and you're saying, okay, no, this is the version of the UI I want to freeze as a snapshot. And whenever the UI changes against this, I'm going to have discrepancies. And of course, you can keep updating a snapshot. And right now we have taken 10 questions, but you can define your snapshot at a question level rather than at a set of questions level, right? So now we've evaluated all these 10 questions, and then we go to the summary. So the summary gives you a table where, let me go to the headers. So you have questions, you have the human response, and you have the LLM-Judge, and the degree to which they agree or disagree. This table is still a little naive because you're only measuring whether, if you said yes, and if the LLM-Judge said yes, it's agreed. But there can be cases where the LLM-Judge gives you an acceptable answer for an unacceptable reason. The reason also needs to check out. So you as a human should be able to overrule. You should say, this is agree and this is agree, but it gave me a wrong reason. So this should actually be a disagree on the alignment side. This is another feature that you need to build out in a real world system. I mean, I guess what I'm trying to also demonstrate here is that you should never leave the part where you're a critical thinker and looking at the system as a whole is never going to get taken over by AI. So those are the parts of your job that are going to keep you relevant. Now imagine that we've done this for about 100 questions, and we don't want to do this every single time we change something, right? It's just going to be really tedious. What we want to do is we want to save this judgment as a snapshot, like I said, and that's what we're going to do with benchmarks. Right now, if I click on benchmark, okay, there are older benchmarks, but there's no benchmark for this run. So what we need to do is, if we want to save this run as a benchmark, we can promote it. And we can do that also by just using a small script. Ultimately, these result files are nothing but JSON files, which have all of this data. And now you're going to just take this JSON and promote it to a benchmark. You're just going to move it into another folder and say, now this is the benchmark. Now what I've done is I've promoted that to a baseline. And when I go to my, and then what we need to do is we can go to the benchmark and say, I want baseline meetup. What does this UI say? It says no judge runs yet for this benchmark. So run some judges against this benchmark, and then we will give you the results, right? So now you have a human evaluation which stands as a benchmark. You need to run some LLMs against this. So now I'm going to say baseline meetup because that's what we called it, and then run the benchmark again. The default model is going to be 4.0 mini, but then we can replace it with 4.0 because those are comparable models. And the advantage of using these O models is also that you can set temperature parameters. And I think after that, at least with the OpenAI models, you don't have you cannot configure the temperature models anymore, temperature settings anymore. And I already had an API key with this, so I just decided to use that. Additionally, when you perform the benchmarks, you can also add a column that shows you the cost. And then you can actually optimize for cost. Right? And whenever you show cost metrics to business people, they start listening. So that automatically gets their attention as well. Yeah, now that we've done this, I can just reload the data from the disk. And that's what we see. So GPT-4o has 8 agrees and 2 disagrees. And GPT-4o mini has 8 agrees and 2 disagrees. In this case, at least at a cumulative level, they seem to have like the same amount of alignment with the human being. But the conclusion here is, if this were a real case, you can say, hey, the smaller model works fine for me, so I don't need to scale it up. bear in mind that we've done the benchmarking on the LLM-Judge. You can just as well keep the LLM-Judge constant and do a benchmarking on the LLM that you use for the RAG model. That will be a different process, but you can use this benchmarking as a technique for modifying several parts of your system and trying to say, where am I going to optimize, where am I going to run the benchmarks. If you go further here, you also have a little more data as to where exactly the agreements or disagreements are happening, right? And all of this UI is really, really easy to bootstrap. I mean, with agentic coding, this is just a matter of minutes. It generates these UIs very easily. And therefore, what you typically want to do, even for your own LLM-based applications, is to build these throwaway UIs, build them exactly as you need it for your team, rather than resorting to, I don't know, some provider who's trying to give you, trying to sell you their UI and their approach. So what you're trying to benchmark against is this. These are the values that are saved at the benchmark. The human tick mark with no comment. That's part of the benchmark now. So it's the human judgment which is part of the benchmark, right? And that is preserved now. I have taken, for example, we did this human alignment run, right? Like for 10 questions. Imagine we had 100 questions. Imagine we took 3 hours to go through the whole thing. Now I can use that for the next 2 months as a benchmark, where this human is always going to be constant, but I'm going to keep running the tests against new models that come out, right? So the human part of this stays constant, and it's saved once. And in this case, I mean, the whole activity is called benchmarking. What I'm calling that is a baseline, because that is the that's the means for comparison. Bear in mind that you need to think of evals a little differently from automated tests. When it comes to automated tests, you typically want systems to pass all automated tests, and you want to use them as quality gates. With evals, they should not be able to pass more than 70 to 80% of the evals, because otherwise you're not pushing the boundary of the system enough. You're actually leaving value on the table, or rather your evals are not giving you new insights as to where the system needs to be optimized. So you need to reveal real engineering trade-offs with these evaluations. So those are ways in which they are different. Yeah, I mean, two things worth pointing out, right? First thing is the domain expert doesn't need to understand the AI system under test. The domain expert just needs to understand what is my response from the AI system and what is the ground truth. And they can find, they can refine the ground truths. They can provide critical analysis on the system's behavior and pass that to the engineering team. Now, the engineering team has enough information to reconfigure their system to make it better aligned with the domain expert. That's point number one. Point number two, your domain expert's time is valuable, and therefore you're trying to take an LLM judge to sit in for them. And once you have established enough alignment between that LLM judge and the domain expert, you can use them less frequently. You can't replace them, but you can use them less frequently. So those are two big takeaways, and you need to do this in a structured manner. Otherwise, it's very easy for you to get, you can't rely on things like intuition here, because two tests might pass and then they might not pass again. Secondly, what I failed to mention again is you need to make reruns of this to make sure that these results are consistent. We just evaluated one run. But typically, you want to have retries to say that this result is consistent enough for me to then go ahead and do the benchmarking.
And what's in your experience with this system? Because
I have some kind of tips on top of what you've said. I would love to discuss them later with you personally, because it's more about the architecture. What I wanted to clarify is that
so just some takeaways which I already mentioned. So go for simple pass or fail for initial alignment. Some of your evals should fail. Try out the demo. All of this code is available to you. And don't trust their benchmarks. Build your own. This is what we saw. I mean, we speak about new models dropping. If you look at what Anthropic said about Opus 4.7, they perform better on all those Trust Me Bro benchmarks that they publish. But if you look at this LinkedIn post, which is linked, there was like somebody who actually had this sort of an eval system and said, hey, I see so much degradation when it comes to 4.7, and this person is not alone, right? Like, so this isn't like some freakish statistical artifact, but we actually do a lot of hands-on projects like this. This is less research and far more practical, right? Like, it's more craftsmanship than, scientific research. And this is also the kind of work that we do, and we welcome collaboration here. And you can collaborate on this. Typically what happens is I start something like this and Vitaly takes it and makes it 10x better. So you could be that person who takes it 10x, makes it 10x better here, in this case, even you. Yeah, there's an immense amount of technical papers I've read to understand some of these underlying concepts, right? In fact, in this repo, you will have access to a curated set of papers that I've used to understand evals better. And right now, the field is moving so fast that what is technical paper to yesterday is already sometimes redundant. Okay, so thank you very much. I mean, it really means a lot that you stayed back and listened to this. So thank you.